there's something different here. And it's not going to be obvious to most people, but this word right here, factor, it means two different things to us right now. We've done two different things with this word. We have done some problems where you look at everything and say, what do they have in common? Let's take that out. And now we've done it with problems where we say, hey, it's a quadratic trinomial. Let's use the x method. But here we actually have both. Look at this problem. The numbers 4, 26, and 30 do all have something in common. 4, 26, and 30 are all multiples of what? 2. But this is also a quadratic trinomial. I have something times x squared, something times x, and a constant at the end. Which means that in this problem, I could do both. So then the question is, well, which one should you do? Or if you do both, what order are you supposed to do things in? And it's very specific here. You have to do one thing before the other. You absolutely must, every single time you see that word factor, anytime you see this, you have to start by asking yourself, do they have anything in common? And if they do, you have to take it out. So, for this problem, do they have anything in common? Yes. You just told me what it was. It's a 2. So, you have to start by taking that 2 out, which makes this now a 2x squared, a 13x, and a 15. So I took out a 2. All of these things were multiples of 2. And remember, when you factor out what they have in common, you're filling in what you need to multiply to get back here. 2 times 2 makes 4. 2 times 13 makes 26. 2 times 15 makes 30. So you took out what they have in common. Now you will set up the x method, and you will only use it for this part in the parentheses. So go ahead and set it up. A times c, 2 times 15 is 30. So I need two numbers that multiply to make 30. B is 13, but they add to make 13. The denominator, A, is 2. So I'm setting up the x method using the quadratic that's in the parentheses here. So someone please tell me, raise your hand if you know this, two numbers that would multiply to make 30, but if I add them, they make 13. If you multiply them, you get 30. If you add them, you get 13. Hannah? 10 and 3. Please do not forget to reduce. This one becomes 5 over 1. And now we can write our final answer. Here's something that a lot of people overlook, though, so please pay close attention to this. Looking at the x method, this obviously makes 1x plus 5 and 2x plus 3. This is not the correct final answer. To do this means that we have completely left something out. Carson?
You gotta put the 2 in
The 2 that I took out to begin with is still there. And I want you to stop and notice why it has to still be there. If all I did was write down the numbers from the x method, if I try to multiply them together, I get x times 2x. That'd be 2x squared, but look at the original problem. I want 4x squared. It still needs to be doubled. I would do 5 times 3 and get 15, but look at the original problem. I want a 30. It still needs to be doubled. That 2 that I took out at the beginning is something that needs to be there in the final answer to get all the way back to the original question. This is not something that happens often, but when it happens, you absolutely must have this, otherwise the rest of the problem will fall apart.